houses or in the mountains. So what they do, they call the police, is a special division called Guardia Civil, right? Like civil guard or something like that. And they have a division, a bomb squad, yeah, for that. So the first thing they do is to tell people, is like they're going to disarm the bomb. That's the idea of solving this equation, you know, the analogy. The first thing they have to do is tell people, go away. This bomb didn't explode for make the count, you know, like super old. It's super old, but it could detonate, it could explode just now. Okay. Come on, I want to see how you do it. No, you can't. I'm going to risk my life, but you don't have to. You don't have to. You're not going to. So the first thing to solve an equation like this, you know, is like a bomb that's trapped inside. You have to open it and take the detonator away or something like that. I don't know, I don't have an idea of bombs, but yeah. So the first thing is to get away from people. So I'll do this. And I have the exponential alone. And then how do I disarm the bomb? So exponential is a function, remember? So I have from an x, I get an exponential of x. And some functions, and I don't know if it happens to all of them, but the more common, they have like the villain, the anti-function, okay, the inverse function is called in maths. So from here to here, I will use the exponential of x, and from exponential of x to x, there is an inverse function called natural logarithm, okay? Natural logarithm. It's not very natural for me, logarithm, okay? We will talk about logarithm one day, if you like. In Spanish, we call it Neperian, no? From Napa, which is one Scottish mathematician. So, but in English, called just logarithm or natural logarithm. You can find it written like this, like Neperian logarithm, or just logarithm. But yeah, it's not the notation is not common, so I'm going to use this ln, right? ln for this. So this is the inverse. The natural logarithm is the ln. So when I do ln, the natural logarithm of exponential of x, I have x. So the exponential does one thing, and the logarithm undoes this thing. So it's very helpful here because I have an exponential here. And what I really want is solve for alpha. I want to have alpha. So the natural choice, the logical choice would be apply the natural logarithm. But you see, as we have an equation, remember we discussed about an equation in previous videos, and now in the description box, if I remember to add the link. What do you do in one side of an equation? Because it's an equation, you have to do it at the other side. Otherwise, it's not an equation. So equation is just something is equal, but if I do a change in one side, I have to do the change to other side. So if I apply logarithm to one side, I have to apply logarithm to the other side. So I would have logarithm of y over y0 is logarithm of exponential of minus alpha x. As I told you, the exponential changes minus alpha x to exponential of alpha x, but the logarithm undoes this, so this is just minus alpha x. Okay, you see, similar what we did here. Logarithm of exponential of x is just the x. Okay, and let me write it better because minus alpha x. So if I want the alpha, what I have to do is to multiply by minus 1 in both sides and divide by x in both sides. So so if I do this, I will have the minus right here, minus logarithm of y minus y0 equal alpha x. Okay, the minus in both sides, minus is plus. And then if I divide by alpha in both sides, the answer will cancel, the alpha will cancel away, So I will have minus 1 over alpha logarithm of y, no, minus 1 over x, sorry, because I forgot that I want is alpha, not x. So I should divide by x if I want the alpha. So like this. If I multiply by 1 over x, this will cancel, will give 1, and the x will be here. So minus 1 over x logarithm of y over y0 will be equal to alpha. So it doesn't seem very useful now, but that's the way of going from this equation. Remove what I don't need. This is really very mathematical, you know, but yeah. For me, the difficult part in physics is maths. So once you disarm, you know, once, because you understand, they don't have a power to over us. So that's why I solved this exponential equation. So remember, I'll give you an example. We don't have make a connection with anything physical. Okay, you just get an equation. Okay, but I couldn't help tell you the physical explanation of the coefficients. Y changes when x changes, and then y0 is the initial value, and alpha is related to the rhythm of variation, because I'm a physicist and everything must have physical meaning for me. Okay, so how to get alpha? If I want to solve this and I make the analogy of a bomb, what you have to do is to leave the exponential alone and then apply the inverse function. You know, there's an arm in a bomb. A bomb explodes, so I'm going to make it not exploding. Why? You know, the key point is removing the detonator, and here is applying the inverse function of the exponential, called natural logarithm. But since it's an equality, I think you call, yes. So what I do on one side, I have to do it in the other side. That's the rule. You know, you have to love your children equally. Okay, what you do to one thing, you buy a car to one thing, you have to buy a car to the other, because they are the same in your love. Okay, yeah. So apply logarithm to both sides, and as you see, logarithm and exponential cancel away. Okay, so, and then yes, that was this equation. And then to get rid of the x, I multiply by 1 over x on both sides, and finally I got the solution. Okay, we're going to use this later. But not now. I thought it would be longer. Let me think if I can continue until I have 27 minutes left. That's good. I'll stop and think about how can explain next. Okay, bye.